On the log scale above, determine how many magnitudes larger the value of d is than the value of c. Notice how the value of d is 10 to the fourth and the value of c is 10 to the second. Let's begin by reviewing how we determine the order of magnitude. If we're given quantities a and b, we use the following formula to determine how many orders of magnitude a is greater than b. So the difference in order of magnitude is equal to the common log of a divided by b. To understand the meaning of this, if one quantity is 10 or 10 to the first times larger than another quantity, it is 1 order of magnitude larger. If one quantity is 100 times or 10 to the second times larger than another quantity, it is 2 orders of magnitude larger. So notice how the order of magnitude is equal to the exponent on 10. And remember, exponents are logarithms. So going back to our example, the difference in the order of magnitude is going to be equal to the common log of the value of d divided by the value of c. So the value of d is 10 to the fourth, and the value of c is 10 to the second. Let's go ahead and simplify this quotient. The bases are the same, and we're dividing, and therefore we subtract the exponents. This is equal to the common log of 10 raised to the power of 4 minus 2, which would be 2, so 10 squared. So because this quotient is 10 squared, this tells us that 10 to the fourth is 10 to the second, or 100 times larger than 10 to the second. And the value of this common log gives us the difference in the order of magnitude. Now we could just type this in the calculator, but because this is common log and we have 10 to the second here, let's evaluate this by hand. So if we let x be equal to the difference in the order of magnitude, we could say x equals the common log of 10 to the second. And now if we don't recognize the value of x here, we could write the log equation as an exponential equation. Let's quickly review how we do this. If we have log base b of c equals a, the equivalent exponential equation would be b to the a equals c, where b is the base, a is the exponent, and c is the number. And because we have common log, we know this is log base 10, so the equivalent exponential equation would be 10 raised to the power of x must equal 10 to the second. Another way to form this exponential equation is to start with the base and work around the equal sign. We would have 10 to the x must equal 10 squared. Now looking at the exponential equation, because the bases are the same and these are equal, the exponents must be equal, and therefore x must equal 2. And therefore this tells us the value of d is 2 orders of magnitude greater than the value of c. So because d is 2 orders of magnitude greater than the value of c, this tells us that d is 100 times larger than the value of c. Let's look at a second example. Same question, but now we're asked to determine how many magnitudes larger c is than b. Notice the value of c is 10 to the second, and the value of b is 10 to the negative 1. So the difference in the order of magnitude is going to be equal to the common log of the value of c, which is 10 to the second, divided by the value of b, which is 10 to the negative 1. Let's go and simplify this quotient. So we have the common log of 10 raised to the power of 2 minus negative 1, which becomes 2 plus 1, which is 3. So this tells us that c is 10 to the third, or 1,000 times larger than the value of b, but the common log of 10 to the third gives us the difference in the order of magnitudes. So again, if we let x be equal to the difference in the order of magnitudes, we'd have the log equation x equals the common log of 10 to the third. Because we have common log, this is log base 10. Again, if we don't recognize the value of x is going to be 3, we would write the equivalent exponential equation, which would be 10 raised to the power of x is equal to 10 to the third. So if we have 10 to the power of x equals 10 to the third, because these are equal and bases are the same, the exponents must be the same, and therefore we know that x equals 3. So this tells us the value of C is 3 orders of magnitude greater or larger than the value of B. I hope you found this helpful.